So now team member Mr. John Pinto will continue with the hands-on session. So John, over to you.
Thank you, ma'am. What I will be doing is I'm pasting a link to our spoken tutorial. Okay, this is the tutorial that we will be doing. We will be creating a 2D channel geometry and meshing it using a block mesh utility. So what we have observed is for some of us, when we are playing this spoken tutorial, the video is not moving forward. Yes, we are only able to hear the audio. So in that case, what you can do is you can even go to our YouTube channel and follow the same tutorial.
Sir, I was facing the same problem. If we are using Mozilla Firefox, it is working, but not in Chrome.
Yes, with Chrome we are having some issues. So what I'll do is I've pasted the spoken tutorial link. Just give me one minute. I'll paste the link for YouTube also. So I've pasted one more link. So first one is the link for our spoken tutorial. Over there you will get some additional reading material and case file, whatever is needed. And the video you can watch from YouTube as well if you are having such problems. Or if you switch to Mozilla, then also that is also fine. But if you are on Chrome and you're facing this issue, then this will be able to resolve it. Okay, so because what we have observed now is that we have a range of candidates with us, right? Some are using OpenFOAM and some, so they know all this command line interface and they are able to pick up very fast. So you can watch the video, go ahead and do that. For those who are struggling and who are saying, I'm not able to understand this command, what I'll be doing is I'll also be following that video, the spoken tutorial, and I will also will be giving you some comments so that you can follow it with me slowly, so that you understand and pick it up, so that from the next video you will be able to follow it yourself. So I'll try to share my screen and do that. For the ones who are pretty comfortable, you all can go ahead, watch those videos and do that tutorial and understand that. Okay, so we'll be following our 2D channel geometry. So as sir said, some of you are struggling because this command line interface, that whatever we are doing in the terminal, the commands seem to be like very big. What we are doing, we do not understand. So we'll go from scratch. So first of all, I'll quickly tell you where we have installed. So if you open your file browser, all of you, okay, file manager, file browser, whatever you want to call it. If you open it, you see on the left hand side over here, there is a Ubuntu file structure, right? When you click on it, all your Ubuntu installation is in that. Now, OpenFOAM gets installed in this OPT folder. So you can open OPT, and in that we have installed OpenFOAM 9 and ParaView version 5.6. So I'm opening OpenFOAM 9. Please mute yourself. Yes. Okay. And in that there are different what you can say folders where different files are needed. Right now, what is important for us is the tutorials folder. Okay. If I open tutorials folder, these are basic tutorials which are ready-made set of files, for some basic simulation, so that we know what is the case structure and how the simulation works. Now, for this 2D geometry, what we will be doing is we'll be copying a tutorial case from incompressible tutorial. So we have to go to, after this, please open the incompressible folder. In that, you have to go to the simple form folder. Yes.
Sir, in my laptop, Ubuntu is not directly opening. I just have to open the command prompt and after give the command of WSL.
No, did you see from where I opened? Your file structure should be there for you in Linux.
Yes, sir, but it is not showing in my laptop.
Okay, so Biraj, can you see? Yeah. Okay, you share your screen with Biraj. He will handle that. Hello.
I could open the Ubuntu like folder, but I couldn't see any tutorial in there.
Ubuntu folder you opened?
Yeah.
So I said after you open the Ubuntu folder, you have to go to OPT.
No, sir, there is no. Yeah, there is there. Yeah.
So please follow quickly.
Yeah, sure, sir. Thank you, sir.
Okay, so go to the OPT folder. After OPT, go to OpenFOAM 9. And then go to tutorials. Now in this, there are many sets of tutorials. Now, for now, our geometry is similar to the channel 395 geometry. So we are opening that. It is in incompressible. So go to incompressible folder. In incompressible folder, there is pimple foam. We have to open pimple foam. Inside pimple foam, LES folder. And inside that, channel 395. So if you see, there are a lot of folders over here, right? Zero, constant system, all those things. I'm going back. So we have to copy this whole channel 365 folder and take it into our run directory. And this whole process that I showed you is done by just one command over there. That is cp-r in the video. If you see cp-r $foam tutorials. But for people who are not understanding, we are just basically doing this. We are copying this folder. Okay. Once you come over here, you right click and select copy. There's the copy option. Okay. Or just do Control C. Oh, here, copy option for me here. This. Press Control C. Now, again, go back to Ubuntu. Your run folder, okay, will be in your home directory. So after I come back to Ubuntu, after copying that, I've come back to Ubuntu. Then I go to my home folder. In that, my username, whatever is the username that you have created, in that, go to OpenFOAM. In that, again, your username will be there with a -9, suggesting that it is for OpenFOAM 9. Then there is a run folder that we created during installation. Now copy and paste over there. Go to a run folder, right click, and then paste. So we have pasted this channel 395 case. Now the second part of this is what we will be doing is opening this channel 395 and deleting the 0 folder.
Hello, sir.
Yes.
Sir, my folder is empty, like this one.
Which folder is empty?
Sir, OPT.
OPT folder is empty.
Yes, sir.
So you have not installed properly. Were you able to do
Yes,
all
sir.
your?
Yes, sir.
If that is the case, then I think then you might have installed in root. Okay, you might have installed in root. Do one thing. Write in chat. Biraj will help you. Biraj or somebody will help
Okay.
you. You might have installed in the wrong folder. If you install as a root, then it will be in the root directory. Your installation files go into the root directory.
Okay, sir.
So where to paste channel 395 file?
In your run directory. So go to Ubuntu, right? Back, then go to home. In home, your username will be there, whatever it is. Okay. In that, there will be an OpenFOAM folder. Again, in that, there will be your username, and in that, run folder will be created, RUN. This is like a directory where you keep all your simulation files. Okay. You don't want to, mess up the tutorial files. So we don't make any changes into the tutorial files of OpenFOAM. We copy that file into this run directory. Okay. And you paste it over there. So now you can edit this.
Inside the run.
Yes, inside the run, paste it over there. Now delete the 0 folder. Because why we are deleting 0 folder is because in this tutorial, we are only learning about meshing. We are not setting up the case. So 0 folder contains the initial and boundary conditions, which we do not need. So we are deleting that. So right click on 0 and then delete.
Okay, so actually it is showing an unexpected error is keeping you from deleting this folder.
Are you getting that error?
Yeah. An unexpected error is keeping you from deleting the folder. If you continue to receive this error, you can use the error code //
Okay.
So it is prohibiting me to delete the folder.
Okay. So I think you have to delete this from the terminal itself. So do one thing, launch your Ubuntu. So follow this. In the search bar, go to Ubuntu. Now, whenever you open Ubuntu, it goes to directly your home directory. This tilde is a home directory. From
Okay.
there, you type this run.
Hmm.
Okay, everybody please do that. When we go to the run folder, now if you see, if I do ls, what I'm saying is what are the files in my run directory. So there are 3 files, 3 or 4 files in my case. So we want to go into the channel 395 folder. So to go into the channel 395 folder, I will type cd space channel. I don't need to type the whole thing. If I just start and then press tab, it will automatically fill that. So what I'm doing is I'm going to channel 395. So is
Sir,
everyone
for me
following
also
this?
channel 395 not showing, sir.
You did not paste it in run directory then. Did you paste channel 395 in your run directory? Without
But
doing that,
I checked in the home also, but it's not showing.
Sir, I couldn't see my run directory.
Okay. Now, okay, Viraj, please handle these cases. I think for you, then you might have not created a run directory, so that might be the problem with. So for people who might have faced some problem in installation, you might have not exactly created your run directory, or you might have done your installation in some other, instead of doing your installation in OPT, you might have done your installation in the root directory. So that might be the case. So please, Viraj will share some a Google Meet link. Join over there. He will handle that. So for you, because of that installation problem only, this might be the case. For the others, now you have to go to the channel 395 folder.
Hello.
Once you do that,
excuse me, John.
Yes.
I think this channel 395 example is not there in OpenFOAM 2312. Can you just quickly share the folder in the chat box? I can just copy it and.
Yeah. So yes, channel 395 is not there. We specifically told you to use OpenFOAM 9. We will share that with you. That is not a problem. But the rest of the tutorials you will have a problem, because we have created everything to work with OpenFOAM 9. As sir said, when you switch between different versions, you are going to have a problem.
Yeah.
So that's
No
why
worries.
we have specifically said install OpenFOAM 9. So maybe after this session, what you can do is install OpenFOAM 9. You can have different versions of OpenFOAM in your system. You can have 2-3 versions. That is not a problem.
Yes.
Okay. So maybe if Harish is there, Harish, can you copy the channel 395 and hand over some link for this person?
Yes, sure, sir.
Yeah. Okay.
Thank you.
Yeah. So now once you enter into channel 395.
Hello.
Yes.
Sir, while deleting the 0 folder,
Yes.
it shows a next window like a try again. It may be deleted.
Yes. So what I'm saying is it may be a permission error that we are getting, so it is not able to delete. So we can delete it from the terminal. So open your terminal, go to the run directory as I have done, and go to your channel 395 folder by pressing the cd command. Okay, by typing cd and the name of the file. Now I am in the channel 395 folder. When I am doing ls, you see there is a, okay, my 0 folder got deleted. Good. So the 0 folder got deleted. So it's not there. Now, what we have to do is we have to edit this. Okay, it might have been deleted, but it is not showing. Okay, so don't worry about that. Just go to your system folder. If the problem persists, we will delete it again. So in your
please refresh it. You will find it. It will be 0.
Yeah, I think so. That might be the problem. Okay, so in the terminal it is gone. That means it is able to delete. So just refresh it. It is gone.
It is gone.
So open your system folder. In that, the blockmesh.dict file is there that we have to edit. So open the blockmesh.dict file with Notepad. If you double click, it will ask. So you open it with Notepad. So this is your blockmesh.dict file. Now this is for this channel 395 case. So we don't want all of this. So what we'll do is we'll remove this command and add set of new commands for our case. That file is already available. So you have to open your this spoken tutorial. Here is my spoken tutorials page. So on the spoken tutorials page, if you scroll down, the code files are available. So your text file is there for the channel. You can open that. Okay, it downloads the text file. Once it is downloaded, you can open the folder location, right click it and extract it. It will be downloaded in your downloads folder. Okay. From there, open this text file and copy the vertices all the way up to the merge patch pairs. Copy it. Now close this text file. Okay. Minimize it. So I am going back to my block mesh dict. Now, in this block mesh dict, these are the old files which are there. So every time we do this, what we do is we copy the block mesh or some file structure from a tutorial case, so that we don't mess with the structure whatever is there and change only what we need. So right now we'll leave convert to meters as 1, right from vertices all the way up to our merge patch pairs. I'll delete everything from my block mesh dict, and after deleting it, I'll paste the new text that I copied. This text we have already written it for you. So here if you see, there is a bottom wall, top wall, back wall, front wall, inlet, outlet, everything is defined in this. Okay. I'll just show you how to run, then we can see how to change the things. So once you have pasted this, so I'll repeat again, in a block mesh dict, right from vertices all the way up to the last command, you delete that and paste the text that you had copied from the file that you downloaded. Is anybody having problem in this?
Hello, sir. Sir, can you again just tell me how to copy this path from that spoken tutorial, because I got missed.
Yes. Okay. So you have to open your spoken tutorial website. Yes, the link that I had shared. In that there is a code file section. Okay. If on the right side, if you scroll up, this is your video, right? If you scroll down a little bit, on the right side there is a code file section.
Okay.
When you click on this text file, it will create one. It will download it. Okay. Then go to your downloads. Open your download location.
Okay.
And in that, extract it, and there will be a text file named as channel.
Okay.
Open that channel and copy this text, whatever is there.
Okay.
And then
Copy the whole thing.
Yes, the whole thing. Copy the whole thing. When you are pasting it in your block mesh, remember, don't delete the convert to meters.
Okay.
So go everything below convert to meters, you delete it, and then paste this new text that is there. Okay.
We have to copy full up to. Sir, we have to copy full text. Kya?
Yes, you have to copy the whole thing.
And then paste whole thing.
Yes. So this is your channel. This is your channel, right?
Okay.
That you download it from there. You copy the whole thing, the whole.
Okay.
It is still merge patch pairs, all. The whole text. Just do Control A, Control C, then go to your block mesh dict. Your channel's block mesh dict will look something like this, right? For everybody.
Yes.
Yeah.
So with 2 blocks. Okay. Now you have to delete everything from vertices. From vertices all the way up till down, you have to delete everything and then paste the text that you copied from the channel. So your new block mesh will look like this. Okay, with convert to meters, vertices. Is this done till now?
Yes. It's there.
Okay.
Yes.
Okay. After you do this, then save it and close this block mesh dict file. Okay. That means now you have edited your files. Okay.
Hello, I have one
Has
small
everybody?
Sir,
Yes.
Yeah, so while you deleting this
sir,
folder,
after
I wanted
copying
to
and
ask.
pasting the file.
Yes. Please. You all speak one by one. Okay. Two people don't
I'm
speak
just
together.
asking what is the difference between that 0 folder and 0.org? I mean, those are the
Okay.
same.
Okay. Good
Because a lot
question.
of time I see the org file is there.
Yes. So generally, right, I have told you to delete the 0 folder because this 0 folder was already there, and while creating,
Yeah,
they had
that
already created a 0.org folder.
Understand.
So instead of deleting the 0 folder, what we generally do is we rename the 0 folder as 0.org. But since 0.org folder is already there, we had to delete the previously available 0 folder in that. So why we need to do this is, if I do not, what you can say, right now we are only doing the block mesh. That we are only creating the geometry. We have not yet defined what are the boundary conditions for that. But to view the block mesh file, we need to run the parafoam utility paraview. When we do that, and if our zero folder does not have the necessary boundary conditions and initial condition, then it creates a conflict, and parafoam cannot open it, because parafoam will search for that zero folder and try to see what are the entries for that. Now, when we are initially trying to do a simulation, a first step is only creating the geometry. Boundary condition will come later. So that time, that should not interfere with the geometry creation. So we rename the zero folder from 0 to 0.oric. So paraview does not recognize that, and it will not read the zero condition. It will not give us an error. That is the general thought process behind it.
Okay, understood.
So has everybody now copied and
Hello.
edited the? Yes.
Sir, after copying and pasting the things, I will save the file or directly close it, that block
No,
mesh
no, no,
chat
no. You
file.
have to save it. You have to save it. After
Okay.
copying, pasting it, you have to save it and then close it. So if you see now, if I open my BlockMeshDict again, it should reflect the changes. See, it is reflecting the changes, right? Otherwise, it will use the old file only if you don't save it. So you have to save it. You have to save and then close the file. Yes.
After say folder 365, what is the next process? Channel 395.
Yes. After copy pasting it, you have to edit the BlockMeshDict folder that is available in the system folder. So in your channel 365, there will be a system folder. Yes, you open that system folder, open the BlockMeshDict, and you have to edit it. I have already edited it. And you have to paste the contents that you download from this spoken tutorial website, right? In this website,
Sir, edit in BlockMeshDict.
Edit in, what are you trying to say?
Sir, actually, edit in BlockMeshDict now.
Edit in BlockMeshDict now. What are you trying to say? I didn't understand.
Sir, after copy the channel 395.
Yes, you copied channel 395. Yes. Then you go into that channel 395 folder. There was some zero folder which you deleted it. Now just refresh it. It will be gone. Then go to the system folder.
Sir, actually here two folders, 0 and 0.org.
Yes, leave that 0.org folder as is. Don't do anything to that. Just on zero folder, delete it.
Zero folder deleted. Okay.
Done. Now open your system.
Okay.
Go to BlockMeshDict.
Yes, sir.
Open that in text editor. It will ask you to open it with Notepad. So when you open it in Notepad, then you need to copy the file that is available. You need to edit this file.
I'm just trying to open Notepad. It's not opening my laptop.
Okay, please paste your query in the chat. Somebody will answer that. Why Notepad is not opening in your system? Yeah, Notepad should open, but we'll have to see. You'll have to share your screen, and we'll have to see why it is not opening.
Hello, sir.
Okay. Yes.
Sir, actually, I am opening in Notepad++.
Yeah, it doesn't matter. Whatever text editor, you just open it.
Okay, okay. Sir, what is next?
Next, you have to delete the inside this, everything below convert to meters you delete. Okay, everything below convert to meters, like from vertices onwards you delete, and then go to your spoken tutorials case. Okay. Scroll down, copy the text file that is available in the code file section.
Okay, sir, I am trying.
So once you download that, copy the contents of that file and paste it in the BlockMesh. It's simple. The same thing is available in the video also. You all can go ahead and watch that. So once you paste it, save the BlockMeshDict, close it. Okay. Now you have saved your BlockMeshDict.
You have to save, sir, after that?
Yes, you have to save. You have to save. After copying and pasting, you have to save it.
Excuse me, sir.
Yes.
Sir, can you explain us why we are doing this, or
why we are doing
whatever steps you are following,
yes,
there
because
is
yes,
intention behind it.
yes. Okay. So we have copied channel 395 folder because that block mesh generally it has, whenever we copy, right, we want some folder structure with us already, because whenever we run a case in OpenFOAM, we will need this folder structure. Like if you see zero, system, constant, all of that folder structure we need. So this
what is folder structure?
This requires all the, like if you open zero, if you've seen that something like setting up a test case, in that also if you see any folder will have a zero folder, a constant folder, and a system folder. Zero folder contains the files which give you the boundary conditions. Constant folder gives you the all your transport properties, turbulence properties, and system folder has all the necessary files for your meshing, control, what are the solution schemes, everything that you're using, and for some additional functionalities, whatever you may need. So this sort of a structure is needed. So we are just copying one case that is familiar or that is more similar to our case, and we are editing it.
What's in the zero file which we deleted?
So that we deleted because right now we are not setting up a case. So if we are setting up a case, what we do is, if we are only doing block mesh, that is what I said, we just rename the zero folder to zero.orig. Because if I don't do that, okay, I'll show you. If I don't do that, I say where is that? I rename this, okay, and I keep it as zero only, okay. Now you see I have a zero system and zero constant and system folder. I have changed the block mesh file. I want to run the block mesh command, but if you see, I will have an error. Okay, I am in my channel 365 folder already. I am running the block mesh command. Block mesh will run as properly. Okay, I have already meshed you see this coming, right? So it has created all the patches, everything, and it is giving a summary, how many pieces are there for inlet, top, bottom. But if you remember, I have not edited my zero folder. I have not made any changes. Now, if I try to view the result using parafoam command, it will give me some error. It will show error. It will show an error because our boundary conditions are not available. So instead of that, what you do is you rename the zero folder to zero.orig so that it does not read this zero folder. And you are only able to mesh it. So once you are able to mesh it and you are able to see the mesh, then you can go ahead, then go to the next step of defining the boundary conditions. That time you rename the zero.orig folder back to zero folder, put all the boundary conditions, and then you can proceed with the next steps.
But already zero org folder already there, no, sir, already.
Yeah,
because no, this is already there because this case has that. So if you copy some other case, right? Where is my tutorial case? Okay, they will not have that. So in that case, it may create a problem. Okay, now let me go to, say, I'm going to OPT, OpenFOAM 9 tutorials. Say let's look at, say, cavity tutorial. It will be in incompressible, icofoam, cavity, and cavity. Inside this, see, zero is named as zero only. So if you change the block mesh dict of this, okay, and if you modify the block mesh dict of this file, then it will give you an error because it tries to reach the zero. So that time you rename this folder from zero to zero.orig. There it was already done, but one more zero folder was already there with you, right? That's why we told you to delete. So it will be from case to case basis, but generally the structure will be zero, constant, system. Okay. Now, has everybody done this? You edited that, then go to block mesh.
Sir, I have not yet done, sir. I have just joined. I was struggling to the run folder. Can you please help me?
Okay, so now in that case, you mention in the chat, somebody from the team will help you. Okay, I want to go ahead now. Okay, now once we have done the mesh, what we can do is we can run the parafoam command to view our mesh. Okay, I'm having some. Okay. Okay, sorry, I'll have to restart my system. I'm also having this problem. I think some of you are also having this problem, right? This is some
Yes,
software
sir. This
glitch,
problem
GPU
is coming regularly. What may be the scenario?
But it's working for me, sir.
Yeah, it will work for 80-90% of the people. So only for some of us, there is some, maybe some GPU problem with this. So that's why it is conflicting. Y'all just hold on. I'll just maybe quickly restart my system once.
Okay.
Okay, hold on. So after I restart my system, my ParaView starts to work. So that glitch is gone. So now if you see, I'm in my channel 3. So one thing, so many people were struggling because some command was not working, whether block mesh command is not working, or simple form, or such commands are not working, or even ParaView. For that, you need to be in the correct folder. Right now, you are in I am in my channel 395 folder. Some of you may go to constant folder and then try to run block mesh. It will not run. So you have to come back to the main folder in which your case files are there. So you should be in the folder in which your 0 constant system folder is there. Then you type so now my block mesh is done. I'll again do the block mesh command. So I'm running block mesh again. See, it is done. After that, I'll run the command FOSSEE. PARAF capital OAM. Now, if I click apply over here, the green button, I can see my mesh. Now, to see the internal structure, I have to change from here from surface to surface with edges. Change it to surface with edges, and these are my cells. I can rotate this. So in my Z direction, I've given only one cells. In X and Y, these many cells are there. So this is something that you should see. So if this is coming, that means your block mesh is working and you are able to do it. Now, for those who have done this, the next thing that you quickly can do is open your. So again, I will show you how to do it over here. So you have to go to gedit.
1 minute. I want to ask that that's the error in ParaView. Every time, whatever the scenario will happen, you have to restart the computer or any other.
Yeah, we have found that restarting works, but we have not been able to find a solution to that. Why it is happening? It is happening with selected people only. For me, in my other system, it was not happening. This is a new system that I'm using today. In this, it is happening. So I have found that restarting it kind of bring the system back, and then I don't face any problems.
Okay, thank you.
So now one thing is either I can go to that folder directly and edit it, or I can use the command. So I will also demonstrate you how to do it from the command line. So now I can open it either with gedit or with notepad.exe. So I'm typing gedit. So it will open the blockmeshdict file with the gedit text editor. So gedit is my text editor and my file is in system folder. So I will type system and inside system, so / and my file name is blockmeshdict. So here, every time when you're changing from one word to the other, the first letter of the next word is in capital. So if you see block, B is small, but M is capital and D is capital. So remember that. Once I do that, my gedit will open. So this is what I get, right? So here, what you can do is, I'll try to. So here, what you can do is try changing the number of cells from 40 cells to maybe 20 cells, okay, and then see how your geometry changes. So you understand what is your X direction, what is your Y direction. Okay, and more about this is also available in the additional reading material for you to see. After you change, save it, close it, run blockmeshdict again. To run blockmesh, I'm sorry, you don't run blockmeshdict, you run the blockmesh command. So run blockmesh and then again parafoam. So what you can do is to see the commands that you've already previously used, you can use the up and down arrow key of your keyboard. So it takes you to the previous command. So you don't have to type those commands again and again. Okay, so now I'm using the up arrow key. I'm going to parafoam. So I have changed the cells in my X direction to 20. So if you see the cells in my X direction have reduced. So all these things you can try to understand with this.
Okay. Yes. Hello, sir.
So, yes.
Sir, can you go slow because I'm a beginner. First time I am using OpenFOAM. So you are typing so fast. It's difficult to catch up.
Where are you?
So ParaView is now closed and I am facing gedit block date.
Okay. So you are done. So you type this command, right? Gedit.
Yeah.
space
So earlier
system.
get it is creating problem for me. So somebody suggest me.
Okay. So if that is a problem, yeah, for some people, what happens is this gedit or gedit, whatever you want to call it, is not working properly. So instead of that, you can type notepad.exe. So it will open this file in Notepad. So that is a choice of an editor. It is like opening it with Word, Notepad, whatever. So it will just open. So that is not a big thing. So when you do this, it will open it in Notepad. So see, now it opened it in Notepad. So once it opens, in these blocks, there will be a blocks command where hex, here you are specifying the block order 0, 1, 2, 3, 4, 5, 6 in this case. And here first term is the number of cells in the X direction. That initially was, I think, 25 or something. I changed it to 20. You can change it to whatever. Okay. Try maybe making it say 100 now. Okay. And Y direction it is 25. So what will happen? After every time you make a change, save it. Okay. Control S or file and save. And then close this. So
And
that
sir,
change,
here is hex, HEX. Hex means hexagonal shape.
no, not hexagonal. Yeah, it is a hexahedral shape.
Hexahedral shape.
Yes, not hexagonal.
So
Hexahedral
it's
has
a 3D
6 sides.
geometry.
Yes, it is a 3D geometry. So if you see, I have done that, right? I'll go to I have to run the blockmesh command first. Then, so okay, to run the blockmesh command, you type blockmesh or you just use the up arrow key because you've already done the blockmesh command. So do that. After that, press the up arrow key again, go to and type the parafoam command. So you will be able to see the geometry. Click apply. Geometry is visible, but you are seeing only surfaces. So to see the surface with edge, in the top panel over here, there's a command. So there's a drop down menu from where you select surface and surface with edges. So here you see now in X direction, our number of cells has increased. So if I just click and rotate it, it is a 3D geometry. But our number of cells in the Z direction is only 1. Our number of cells in the X direction are 100. Y direction, I think it is 20.
Hello, sir.
Yes.
Sir, if after editing in Notepad++, what will be the next? Actually, I am facing error in ParaView.
What is the error?
Sir, could not find valid OpenFOAM mesh.
Okay, so after that you have to
like blue
run, no. After you edit and save, then you have to run the command block mesh.
Yes, sir.
So if you don't mesh, then OpenFOAM will not, ParaView will not be able to read the mesh. No? You might have forgotten the command block mesh.
Yes, sir. Actually, I ParaView open, but blue line is showing here.
Blue line. I
Yes,
think
sir,
wait.
blue
You just join a link where somebody will guide you. Okay. For that, we'll have to see what is happening on your screen. Now, after this, I think basically what you need to do, what you need to edit, and where are the files that you've understood. Now go to the second tutorial. The link to the second tutorial I will share.
So there is a constant output message is there, a small window output message.
No, just close that window.
No, it is not closing up. I am clicking on the cross, but it is not closing up.
Okay, so you join the link. So you join the links that Viraj might have shared. Okay, share your screen. He will be able to guide you over there. Okay. Now I'm hoping that at least this everybody might have been able to do. So next, what we need to do is go to the second tutorial.
So before you proceed towards the next tutorial.
Okay. So I'm going to spoken tutorial page and I'm going to the OpenFOAM V7. So we have done tutorial 4, creating a 2D geometry. Now we are directly going to tutorial 11, grid resolution and convergence. So this is something that you all can try now. This is similar, only over here we have to keep changing the size and looking at the output. So I will copy this case. Okay. And I'm pasting it in the chat. Wait. So this is the new tutorial that everybody has to do. Okay, follow this. For this you'll have to run the case 2-3 times. You can
Sir,
watch the
could you
video and
please
follow
send the
this.
YouTube link of this video?
Yes, yes, I'll also share the YouTube link. So I've shared
Okay,
this.
thank you.
Okay, I have also shared the YouTube link for the next tutorial. In that, we will be doing the grid resolution work. So you all can go ahead and do that. It is pretty straightforward. You have to do the editing also. But in this case, after meshing, you also have to run the simulation, which you have already done. If anybody has a problem, you let me know. I will demonstrate it over here again if needed.
Hello.
Yes.
Yes. So I'm not able to visualize this paraview command. So after blockmex, I'm not able to find this paraview. GUI is not coming for me.
Okay. Do one thing. There will be a link over there, right, where people are helping. Just post over there. Somebody will guide you. So you can share your screen over there.
Okay.
And we can look at it. Okay.
Sure.
Okay.
I think he can type paraform, not paraview in the comment.
Yeah, I think the command is paraform only. Is he trying paraview? No, paraform command opens paraview. I have demonstrated paraform only. I don't know. What is he trying? So that's what we have to see his screen. So see, there is a link, right, which Raghavendra has shared. You all join that meeting link. Yeah. Those who have such problems, right, if block mesh is not working or some paraview is not working, just join that link. Yes, somebody is saying something.
Sir, actually, in my Ubuntu, when I am typing paraform, it's
Yes.
showing an error because I have installed the paraview in the Windows, and
Okay. So in that case, because you have installed paraview in Windows, so you don't open from there. You type touch, TOUCH, touch. I'll type in the chat. So what you need to do is you need to type touch, 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 and then some file name. Say result.foam, and when you here touch result.foam. When you do this, a result.foam file will be created in your run directory. Okay. And then you need to open that with your paraview. So to open your location, right, wherever you are in the terminal, from your terminal, in your terminal, like say I'll demonstrate, right? If I'm in my terminal right now, okay, I will type TOUCH touch space, say file name, I'm calling it as result.foam. And if I enter it, a result.foam file will be created. If I want to view it, I'll type explorer.
Excuse me, sir, John, sir.
Yes.
Your screen is not visible.
So you see the first command that I type, result.foam. I'll see if I can actually, which is some. Font.
Yeah, sharing the screen. I think please, Somna, please rejoin.
Here.
I think that maybe a issue.
Just 1 minute. I'm trying to see if I can increase the font size.
Yeah, Deepak, yeah. Just do what I say, okay? Okay. Yes, terminal. Everything, do it in the terminal.
Are you able to?
What problem?
I'll figure this out. Just give me some time. But till then, are you able to see this, right?
Yes.
Yeah. So you have to type touch, then file name dot foam and press enter. Whatever is the file name. Then you want to open that location in your file explorer. So you type explorer explorer.exe and then space and then dot. So what it does is it opens the file explorer in the current directory, that is channel 395. So when I do that, okay, you see this, my file explorer is open and I am seeing this file structure. Directly my channel 395 folder is open and you see this result.foam file is there. So this you have to open with paraview which you have installed in Windows. Okay.
The same thing, okay.
So for me, I don't have it natively installed on my Windows, so I will not be able to show you. For you, you have to right click and then open with and then search for paraview and then do that. Or you can open paraview and then load this file into paraview. The thing is, once you allot this file to ParaView, like open with always, then every time you don't have to do, the ParaView symbol will come and you can just double click and it will open in ParaView. So this is for people who have installed ParaView natively in Windows, because somewhere they were having a conflict with Ubuntu. So you can do this. Yes. So you all can go ahead and do the second tutorial.
Excuse me, you have
Yes.
only one Windows in the system, that only the Ubuntu, no?
Yes.
We are facing that difficulty because we are changing to Windows to Ubuntu.
No. See, I'm also having Ubuntu, right? See, if you see, I'm also having Ubuntu. That's why I'm demonstrating to you on this system. I normally don't work on this system. I have a system which is purely Linux. But because I wanted to have the same problem which you have, so I've taken this system in which Ubuntu is there. Okay, so for me, if I have to do anything, I'm doing it in this Ubuntu, and this is my native Windows, right? This is everyday Windows.
Okay.
See, if you have enough capabilities in your system, if you have enough size, you can do a dual boot. You can install Windows and Ubuntu side by side. You can go and work completely in Ubuntu, and then reboot and work completely in Windows. That is also possible. That is what we do on our PCs over here, because they have good size.
Yes, that PC is very fast for the Ubuntu system.
Yes, so then we are working on that. Now, please go ahead and do the second tutorial, where you have to do grid resolution and convergence. So in that, what you need to try is, as sir mentioned, we will be progressively making the mesh coarser or finer, and we'll monitor what is the effect on the parameter, say pressure in this case. So when we go from a mesh which is having a size of say 20 by 20 to 40 by 40 to 80 by 80, how does my result change? And at what grid size my result starts to become independent of grid size? That is the aim of this tutorial. So you can follow this tutorial step by step. If you have any problem in that, please let us know. We will help you. So it is the same lid-driven cavity case that you all have already run in the morning, right? Same thing, but in that now we will be doing a grid independent study or grid resolution study.
Hello, sir. In morning, I was not able to run the lid-driven cavity. So after block mesh, which command I will use for run the simulation?
In lid-driven cavity, your command will be, I think, icofoam. Just let me confirm once.
Icofoam.
Yes, just give me
yes,
one.
sir. Icofoam was there. So
yes, so it is in icofoam. So icofoam will be the command. Yes.
So directly after block mesh, I
yes,
run the
after
command
block mesh.
icofoam.
Yes, so then it will solve, and after that you have to open parafoam.
There any edits, sir, in directory, block mesh directory?
In cavity, you are saying?
Yes, sir.
Yeah. So I think it is too loud. So what you can do is you have already copied the cavity, right?
Yes, sir. I already copied.
So in that you run it once. Okay, in this system I don't have it. So then you don't need to edit the block mesh dict. You run it once, then follow the tutorial, save the value of p for one grid size, change the grid size, then observe the value of p, see how it is changing. So you change the grid size 2-3 times to see how your p pressure value at the center of the cavity changes with the different grid size. That is your aim. So I'll be doing it. I think people are getting confused. So what I'll do is I'll do it myself. So I already have. So in my run folder, I don't have the cavity. So I have to copy cavity. So what I can do is I can go here. You can type tut. It takes me to tutorial. Then in this, I'll go to incompressible icofoam cavity. So this is my cavity folder. I'm copying cavity, which you all have already done. You don't need to do this to your home directory, which is here. So I'm copying the cavity case. Now, if I have to run cavity, I'll just open it I need to open it in this. So I am in my, I first go to run directory by typing a run, go to cd cavity. So now I am in the cavity folder. Now I can run blockmesh. So just to demonstrate, if I'm not in the cavity folder and if I'm in some other folder, say like, let's say I go to cd system. Now I cannot run blockmesh. If I run blockmesh, it will give me an error because I cannot run blockmesh from system folder. I need to be in the main folder, that is the cavity folder. So I'll go out by pressing cd dot dot. So I've come down, I've come to the cavity folder. Now I can run the blockmesh command. So this is what problem some of you are facing. So when I run blockmesh, my blockmesh is running. Then after that, I have to run the command IcoFoam. So very quickly it solved the case. Then I need to do parafoam to view the results. So once I do this, I click on apply. This is something. Then here I'll go to, sorry, here VTK block. I'll say let's look at the simulation. I'll select U. Okay. I go to the last. I can click play or go to the last one. So I'm at the last time step. Here, what we need to do is we need to note down the value of pressure and velocity at the center of the cavity. So here there is something called as a probe, which is next to this ruler. When we click on that, it will automatically take a point at the center. I'll just click apply, won't do anything. And in this spreadsheet view that comes on the side, it is saying the center location, what is my XYZ coordinate for that center point, and what is the U velocity and pressure over there. So I will just copy the pressure value, or if I will just note it down in my book. Say I'm noting it down. You can copy it onto an Excel so that you can plot it also. Or what I can do is I can click file, save data. So you see one grid one CSV file named grid one has come, in which I have my pressure, velocity, and all those points. So similarly, I shouldn't have saved it here. I should have saved it in my home directory. Outside over here. Say this is for grid one. Then important thing to note here is, I think this, please pay attention over here once. Once you have done that, you have copied the data. In your terminal, you need to clean the case before running the simulation again, because you have old data. You can do that by typing the command, foam list times rm, or you can do foam clean case. Both of them work. So I'm showing to you both. So foam list. So what this command does, so I'll show you. So if in my system over here, in my cavity folder, all these case file results are there, 0.1. So what does this mean? That means 0 is my initial condition. Then it is saving data after 0.1 seconds, after 0.2 seconds. So whatever is the simulation data. Now, before running the simulation again in this, if I want to clear this, I'll just type foam list times space dash rm. When I do this, you see all of this gets deleted. In Windows, I need to refresh it once. So see, all the other files are gone. Now I can rerun the simulation. But before rerunning the simulation, we need to increase the size of the domain. So it is 2020 0. Now I will change it. Now let me see what they have taken over there. So I will take similar. So instead of 2020, we are going to take 40 cells. 40 cells in X, 40 cells in Y. So change the X and Y to 40 and 40. Save this file. All these steps are available over there. So if you have any problem, you can ask me. Or you can see the video as well. But only by changing the block mesh dict it will not work, because once you have made your mesh finer, we have to change the time step as well, because we have to satisfy the CFL criteria, or Courant number criteria. So more information about that is available in the, so I will show you that. So in our spoken tutorials over here, for the last tutorial, grid resolution and convergence, there is something called additional reading material. Okay, I was too fast, I think. I'll do that again. So in that, when you scroll down to the, in your spoken tutorial, if you scroll down, there is something called as slides, script, if some material is there, case files will also be here, and there is something called as additional reading material. When you click on that, one PDF will open up. It will talk about what is Courant number, how is it defined, why Courant number should always be less than 1, and in the grid independent study, what results are we getting. So everything is given over here. You can go over it once to understand this in more detail. It is available on our website. So as you can see, if I am increasing my number of mesh, my number of delta x is decreasing. So to keep, if my delta x is decreasing, my Courant number will increase. So to keep my Courant number in check, I have to decrease the time step as well, that is dt, for a given velocity. And that we do in the control dict file. So we open the control dict file over here in Notepad. And here we change what is called as a time step, that is delta t, time step. Now for this case, let me just see what is the time step that is needed. Here the time step that is needed is 0.0025. Okay. Otherwise, I can show you also what happens if you don't change this. Let me just show you what happens if you don't change this. Suppose if you forget to change this and just run. So I'm back to my terminal. I'm running block mesh command because I need to mesh first, right? Because I've deleted everything, even my mesh is gone. I'll mesh it again, block mesh. Now I will run the simulation by IcoFoam. Oh, so now this, I think I changed and I saved it. If you see, my maximum Courant number is exceeding. It is 1.85, so which is not good here. Okay. If you see over here, my Courant number mean is there, but my maximum Courant number has exceeded it, and it has become more than 1, which is not good. Your maximum Courant number should always be less than 1. So this simulation is not that accurate. I will open my control dict. I will change the time step to 0.0025 and I'll save it. Once I do that, now I need to delete this. So I will do foam list times rm. I have saved that command. I just press the up arrow key, deleting those case files, running block mesh again, block mesh, then IcoFoam. So you see now my Courant number is less than 1. It is 0.9, which is good. So this is correct. Now again I will go and do parafoam, view the results. Say velocity, go to my last time step, then select the probe locator, which is here. The same thing, so I'm doing it a little faster. Apply. Here you see a new value has come for PU. So this, if I want to save again, I will go to File, Save Data. Okay, now previously I had saved in cavity. I'll go up. I will save here. So first grid was G1. Now this grid is G2. So I have saved 2 grids. I'm saving it. I'll come over here in the block mesh. I think I need to do it one more time for 80 by 80. Let me just check that. Yes, for 80 by 80 also I will have to run. I did my block mesh. make this 80 by 80. That means we are successively doubling the mesh size to see how our mesh changes. Now, after doing this, I need to decrease my delta t. What is my new delta t? But I need to also change. Okay, let me just first run it and see how much the foam list times, clear it, run block mesh, and then run icofoam. So you see Courant number is exceeding. That means I need to decrease my delta t again. So I go to control dict. So this delta t which we had reduced for 40 by 40 is still not sufficient if I increase my mesh. So I need to change this to 0, 1. I'm making it 1e minus 4 now. That is 0.0001, saving it. And I will rerun the simulation. But first I need to clear it by foam list times. Then run block mesh. Then next step is icofoam. I think I added one more additional 0, which is too much. So it will take some time to run, but it's fine. Okay. I should have made it 0001. Instead of that, I've made it, 001. So now I'll run parafoam. Again, I will see how my velocity looks. So not much changes there, but I want to look at the. So here you see, if I do surface with edges, we have a very, very fine mesh. Now I'll go to the probe locator, click apply, and it is showing what are the values. I'll again click file, save data. Save. This will be.
Hello.
Yes.
Sir, can you show this file saving step and this center point pressure measurement once again?
Yeah, one minute. I cannot hear you clearly. Just let me see if my okay. Yeah, all okay. Done. Yeah. What was your question? Sorry. Yes.
After opening parafoam,
yes.
there is a one step you did for the for the contour formation, like it is a smooth contour, and to save the pressure value at the center location.
Correct.
That step, can you tell the again?
Okay. I'll show it to you again. So this is our paraview file, right? Maybe I'll open it again so that I'll close it. I'm opening my again by typing the command parafoam. Once it opens, I'll just bring it down. So I first need to click apply. Okay, then I need to say, just for me to see the mesh, I can see it with surface with edges. So if you see, it is a very fine mesh now. And if I want to view the velocity, over here VTK block colors is there. Instead of that, I will select velocity U. And then if I click play, it shows how the velocity is evolving. Okay, but I'll pause it now, go to the last time step because my delta t was very small. Now, after this is what you want to know, correct? Okay, yeah. So
this is I'm getting similar.
Yes. So next, now what you need to do is click over here, probe locator. This is on the just below that surface to edges option is there. Just below that, if you hover over it, it will show you the name, right? It should show the name. It is called as probe locator. See probe location. So when you click on that, it automatically by default takes the point at the center of the domain. Okay. So now when I click apply, what it will do is at the center of the domain, it will tell me what is the velocity, what's the pressure, and what is the coordinates of that point. This is something that I had saved by, once I get this, I can either note it down, or if I want to extract it and create a plot or something, then I need this data in the form of CSV. So that also I can save by going to File, Save Data. Now this window, I'll bring it over here. So in this save data option, it is asking me where to save. So I'm not saving in the case file directory because if I do foam clean case, there are chances it can get cleaned. So I'm going out, I'm saving it over here by some file name. I've called it G1, G2, G3 for grade 1, grade 2, grade 3. whatever file name you want to give, you give that. And from the drop down, you have to select CSV. So there are 2-3 things, right? There is CSV, tsv.txt. So you have to select that value, comma separated value, and then click OK. Once you do that, that file will be done. So that's it. That is what you need to do now. Is that clear? So now for me,
Okay.
I'll just
Yes,
create
sir.
one.
Okay.
I'll just create one new Excel file. In that, I can copy the results for these 3 cases. So we'll be able to look at them together. So see, I have grid 1. Okay. So now this is my grid 1. I'll just copy my grid 1, that is this. This was 20 by 20, correct? So I have size 20. Okay. 20 by 20, 40 by 40, and 80 by 80. For 20 by 20, this was G1, correct? So I'm copying the pressure over there. I'm pasting it. So this is my pressure, and this is my grid size, or cell size, I should say, whatever, number of cells in X. I'll say NX, number of cells in X. Oh, for Y it is same. Now I close G1, I don't want that. I'll go to grid 2. Now I'll copy the pressure value of grid 2. It is, I want to know if I make the grid finer, then what happens. Then I want to know if I make the grid even finer, then what happens. It is done. So now I have this. The thing is, I can plot this by just plotting it. So you see, if I increase my grid from 20 by 20 to 40 by 40, there is a sharp decrease in the pressure. That means the 20 by 20 is not a good enough grid. From 40 by 40 to 80 by 80, there's a slight decrease. Now we can try one more with 160 by 160 cells quickly. It doesn't take much time. So I'm going here, going to my cavity, right? For that, I will have to close my paraview first.
Yeah. Sometimes we are changing the time step size also.
Yes. So we have to change the time step size. For that, I have mentioned, right? There is a document for our. There's a document on our website, right? In the additional reading material, it is talking about the Courant number, right? So in a transient simulation, we cannot have a very large time step. The time step controls how fast your information or how further your information is traveling, right? So that is very important. So depending upon your grid size, your velocity and delta t, how much your information is traveling from one cell to the other. You don't want your information to travel more than one cell. That's why your Courant number should always be less than 1. That is the ideal case. So all additional reading material on Courant number, everything is available over here. You can go over it. So if you reduce your mesh size, you have to, along with that, decrease your time step as well. So to keep your Courant number in check.
Yeah, is there any mandate such that the mesh size should be kept constant in order to select the time step size?
No. We are see what we are trying to do. Okay, we are trying to just let me.
Means I am asking about the time step independence test, sir.
Okay. No, first to get the time step independence test, first you need to do a grid independence test, right?
Yeah.
So before doing a grid independence test, if you try to do both of them together, then it will not work. So you first do a grid independence test, make your solution independent of the grid. Then in that you can change the time step a little bit and see if your solution is changing with time step.
Okay, we are changing time step in order to keep the grid within Courant number, right? CFL
yes,
number.
only within the Courant number. Now,
yeah,
in that,
we are not checking the time step size here.
No. We are doing this. Yes.
Okay.
Okay,
Thank you.
yeah.
Sorry to interrupt, sir. Actually, sir,
Yeah.
I wanted to know that how you are saving that image of that velocity contour to the display in the paraview.
Image, you want to save image?
Yes, sir.
Image or data?
Sir, image that.
Okay. Okay, so just wait, hold on. I will make the changes and I will show you, demonstrate over here. So what I need to do, I need to edit my block mesh now. Make it come 80 160 by 160. I'm saving it. I think my time step is pretty small, so I don't need to change that. I will do block mesh. I go foam. Oh, I think my time step is very small. So just let it run for a couple of minutes, maybe. Just let me see what is the current number. Just 0.1. I could have increased. Okay. So now here what we are trying to do is we are trying to find the point where my my result becomes independent of my mesh size. So I will just label this. This is my pressure. So my number of cells in the x direction. After this, we'll do one more case with 160 by 160.
Hello, sir.
Yes, hello.
Sir, can I use a spoken tutorial?
Can you use the spoken tutorial?
Yes.
Yes, you can use the spoken. I have shared the spoken tutorial with you initially, right? There is a spoken tutorial, and there is if that is not working, then the YouTube video is also there.
No, sir. I'm just like in spoken tutorial, there's so many videos and all. But I'm just try to open the spoken tutorial from Google, and it's asking me for ID password.
ID password. Okay,
Yes.
wait. Just hold on. Just hold on. I will answer your question. So see here, if you go, how are you searching? I don't know, because you just type spoken tutorial. Okay.
Okay.
Then the spokentutorial.org is there. Open that. In that, it will open this file. You have to search in all courses. You have to search for OpenFOAM. OpenFOAM version 7, and then just search. And then this comes. This is free of cost. Hello.
I'm just open it. Okay, so just open it.
Your voice is breaking. So here, then you can watch. You can watch all of these. You can practice along, and it is also freely available on YouTube. The same thing.
Okay, sir.
Yeah.
Thank you, sir.
Now, yeah, welcome. So now this, after this, I'll run FOSSEE to answer the question of. Okay. Now I've clicked apply. My U profile. I'll just take the last profile because I don't want to waste time. Now, if you want to save this, again, now you have to be in this, what you can say, this view, and then click file, either save screenshot. Yeah, here, save screenshot. Again, maybe give you a file name. I'll go and save it outside over here. Maybe velocity and PNG. So my formats are PNG, JPG, TIFF, whatever it is. Save. And then OK. And then if you see in this outside this cavity folder, in the run folder is where I saved it. This velocity gets saved. So I see this velocity profile with my U scale. So it got saved in the resolution in which I was viewing. You can play around with that and see how that changes. But this is how you save it. Now what we wanted to do is look at the pressure. So I'm clicking on the probe locator.
Yeah.
Clicking on apply. Yes.
Sir, do we need to submit this PNG file to you?
No, you don't need to submit anything. That is because just somebody was asking, right?
Okay.
How to save PNG files. That's what.
So there is no assignment part in this workshop.
No, there's no assignment. You have to, it is self-driven. So, you can try changing this values, after this so that you get more familiar. Because tomorrow when you come, you should have a little bit familiarity of this so that you can pick up. So maybe after this session, you can, try running the same commands again so that you become a little bit more familiar with what is the structure. As Sir said, right, and somebody also said, initial learning curve of OpenFOAM is very steep. So it takes, the learning is very slow initially, and then suddenly you pick up because the difficulty of getting used to the command line, getting used to the terminal, that is, and what is the structure, that takes a little bit time. So you all need to practice this. What I was saying, yes.
Sir,
Now you need to
everything in the control dict file, again we have to do the block mesh.
yes. What did you just say?
Sir, actually, after doing the meshing, because of the current number value is very high, again we will change the control dict file, right? Time step size.
Yes, you change the control dict.
After
Yes.
changing the time step size, again we have to do the block mesh, or
No,
directly we can go for IcoFOAM, sir.
No. Best thing is to clean the case again by doing that foam list times.rm. You clean the case again so that if some old files are there, they will not create any problem. Okay. So you after running, see, I'll show you. Okay. Just hold on. Just hold on. I'll show you the steps. Just let me save this. So file. I am saving this data. Just hold on. I will demonstrate that again. I will save this data and this will be grid 4 CSV. Okay, I've saved it. Now see, once you come out, what happens is in your cavity all these files get saved, right? Your current number was high, but still it ran and it gave you all these files. If you don't clean this, then your next simulation files will be overwritten and it can create problems. Some time steps are not matching. So it's always better to clear that. So after that, the command is foam list times -rm. So when you do that, when you run that command, what happens is, see all these files which are there on my left hand side, now they are still there because in Windows I need to refresh it. If I just refresh it, all of them are gone. So it has come back to its initial state. So it only removes the solution files and not your, what you can say, setup. So whatever you change, like zero, a boundary condition, all of those things are not touched. Only your simulation files are removed. And even if you go, I think your polymesh. Okay, polymesh is there. So I think you need to, mesh again. It's better to mesh again. I think foam clean case cleans everything. Yes, foam clean case command is better than foam list times. Foam clean case will clean even the mesh. So, but still after this, you run the block mesh. After you do foam list times, you run block mesh. Then you run the simulation by typing IcoFoam. Okay,
Yeah.
I'm not
Again,
running
after
it.
changing the time step, again we have to do the block mesh, sir.
Yeah, again you clean it, and then first clean the case, then run block mesh.
Yeah.
So just follow this same procedure.
Okay.
Okay, now let's
Yeah,
go
okay.
look.
Yeah, sir, can we get a document in which the meaning of the each and every command line is mentioned?
Okay, so that is also there on our FOSSEE website. Yeah, let me see where it is. For somewhere in some tutorial, right? I think it is maybe setting up a test case or something. The prerequisite, some additional in every case there is an additional reading material. Okay? Or where is that commands for this Linux commands? We have a list of Linux commands, right? Okay, so we will share it to you, but it is there on this website only in some of the things, additional reading material here. Okay.
Okay, so just like we have now Python documentation.
Yes, yes. So that we have one sheet. I will share it with you. It will be in one of these.
Okay.
So like the commands, like whatever you are typing ls or
what does
cd
ls mean?
dot.
RM
Yes.
means yeah.
Yes. All of that is available. Right. Okay, so it has been added in your chat. Just check once. See this.
CFD direct.
Yeah, so this is a general command. We also have one over here. Maybe Biraj is not able to find that, but if you can copy this, it will give you all the basic Linux commands.
Okay.
Okay. It's taking some time to load. Yeah. So, like, what does this mean? There are we have showed you some, right? Like CD, ls. What does that mean? Then say there are some other files like cp-r, mv, rm. So what does all of them mean? So there is a huge list of commands that you can see. It's one page. It's available on CFD Direct. So that link is there, which Biraj has shared. You all can go through it so that you understand what is happening. So it will be better that you all just go through this command once. So tomorrow you are much more familiar with what is happening. Okay, now to go back to what I was doing, I'm just copying this data. Making it over here. This is for 160, and I will just. Okay, so if you see this graph, right? This graph clearly explains that if we move from 20 by 20 cells to 40 by 40 cells, there is a huge change in the pressure at the center. From 40 by 40 to 80 by 80, again there is some change, but from 80 by 80 to 160, there is no change. So you can go for a cell size of 80 by 80. We can also calculate the percentage change.
Why do we check pressure at the center of the geometry?
See, right now we are showing you how to check the pressure at the center, but in the later on sessions, maybe I think day 2 or day 3, we will teach you how to calculate a volume average value that will be much more accurate. Right now, because you are very new, first day itself we will bombard you with so much, it becomes difficult. So there is an option also to calculate volume average quantities, and that is a much better way than doing a point average. Okay, I hope. So between these values, from first value to second value, the percentage change is around 30%. Between second to third, the percentage change between each is 12%. And then between the third and the fourth is 3%. So this is between these 2 points. But here, if we can see, that means the result that we are getting with 80 by 80 cells is not significantly different than by 160 by 160 cells. So you can go for 80 by 80 cells without loss of much accuracy, but with improved, but with a lower computational requirement. So this is something that you should do at the start, to identify what is your grid size that works for you. So this was the tutorial to do that. I hope you'll have understood this. And if you have any queries now, you can write to us on contact-cfd. We will add that email in the chat. And plus, please go through the material that we have given to you, like what Biraj just shared, for the Linux command, so that tomorrow it becomes much easier for you. So I'll just stop sharing now.
So you can also send your queries to our email ID. I'm typing it once again. For those who have any query regarding today's sessions, please type your query here. Okay, so for today, I think it's time to wind up. Right, John, Biraj, can we wind up today?
Yes, ma'am.
Okay, so bye-bye for today. Thanks once again for joining.